and this is my philosophy on most things. Opinions are good only when I agree with them, and so that's my philosophy on code. Basically, that you it's you should read over all these frameworks. You should decide for yourself what you agree with in them. Now that might be a little hard if you haven't developed like your own opinions on like how JavaScript should be done or things like that. But basically, the idea or my thought is like, if a framework has something I disagree with, there's tons of frameworks out there. There's plenty for me to choose from. Now, is there going to be the one framework that has everything I love? Maybe, eventually. But there's lots that are not going to do that. So I'll go with. So, one way to look at it is also like the age of the framework. That's an age definitely has an impact on like how good a framework is because developed at different times. In the case of Backbone existed before a lot of like or JavaScript changes were coming down the pipeline. If we go like Backbone JS started back over 5 years ago, I believe. Backbone JS history. So there you go. It was started October 13th, 2010. I don't know why it says 4 years ago. I guess they don't round. So it'll be 5 years come this October. And 5 years ago, the world of JavaScript was very different. It was highly dominated by, pretty much just like a lot of jQuery and things like that, and very basic things. Backbone helped clear up a lot of that, but it also had a lot of boilerplate you had to write over and over again. The nice thing with Backbone was that it's very small and it's very concise to read. If I go to Backbone.js again, Backbone.js has annotated source code, meaning that I can go and this is all the source code with all the comments next to it. And so you can learn a lot from how they handle things. There's a whole bunch of stuff that you don't necessarily need, like Backbone routers. That's completely different. Backbone history. This is different. I'm sure they've evolved over time, Backbone, with more and more features as time has gone on. Backbone syncing, which is persisting data, and this is your main here's your Backbone view. It's pretty small when you look at it. Backbone view is 10, 30, 35, 40, 50 lines of code. 50 lines of code for Backbone view. This is the model. The model is significantly larger. Okay, it's Backbone collection. So that's probably like 200 lines of code. And this is probably like 150 lines of code. Maybe more now. 200 as well. For the Backbone model. And Backbone events, which is looks like 150. And so you can easily read a lot of Backbone. And that's when I wrote my thing. It was basically I was trying to write a very small, very easy to understand, very terse framework that you can sit down, almost read it all on screen at once. So you can Backbone is like the granddaddy. Angular and Ember. Ember came from Ruby people. Ember I'd always or not recommend because Ember has a history of being slow. and they've improved it steadily over time, but I feel like they're in a losing battle in that Ember doesn't. Here's another way to do it too. Google Trends. If we pull up, search Ember. Okay. Let's see, Ember JS. So I'm going to add in both of them so we can compare them side by side. Ember, you can see Ember.js doesn't really get too many. Ember itself is significantly more prominent. Haha, what the hell is that? Let's see, Ember.js. So let me see if I remove just Ember. That's Ember.js, and let's go with Angular.js. Oops, I actually need to add that. Whoa. Angular.js. So here it compares both of them. You can see Angular is twice as popular, pretty much. I don't know what that is. That's really weird. Oh, it's only partial data, that's why, for May. So if we disregard May and look at, across time, Ember was growing in popularity alongside pretty much Angular, and it's basically around 2013, mid-2013, it lost momentum. Well, I guess at the peak of April, May, it started to lose momentum and has only steadily lost momentum over time. Related searches. So it's lost momentum over time. And now let's add in React.js. And you can see React.js, it just like freaking flew off the rails in the span of a year. Basically, this year, at the end of December, it had already overtaken Ember, and by 2015, it had pretty much overtaken Angular as well. And so here's the thing. Ember.js is, to me, like, it was slow and busted, very verbose. They've improved it. They continue to improve it. They're good developers, don't get me wrong. But I feel like part of the reason things are slow and not as good is because they're the kind of people who over-engineer things. React is and isn't a framework. When I say that is when I wrote Rome. If we were to go by like what React is, Rome is React. I wrote Rome before React existed, and a lot of concepts exist in it before they existed, and kind of like pie in the sky. Like let's see, do I still have it open? You'll see it in like my tagline for it. Helping you conquer with components. I wrote that, you can see my last commit. It was September 19, 2013. So basically, I was writing components in a component-based architecture around this point, search result 3. And my commit doesn't actually compare to when I actually wrote the feature, which was probably back around March of 2013. So For backend, I'm using in this Phoenix framework for Elixir. It's probably the most fleshed out with a whole bunch of things. There are, I think, 2 other web frameworks, but they're not nearly as fleshed out at this point. And so React.js isn't a full-fledged one. Like, okay, so Angular does a couple things. Angular has routing. Angular has the templating. Angular does your two-way bindings, and it does have like resources in a way to like query your data and store your data from the DB, it's technically hitting your server, which has a DB, and then it deals with things through promises and things like that. And so Angular has it all. Angular, though, is overly complex for what you have to do, and it often is painful because when you start diving into filtering and directives are some of the most painful thing I've ever had to do. Reason being is like you sit down and think to yourself, hey, I can write this by hand in JavaScript hella freaking easy. To do it the Angular way with directives is often extremely painful. It's like twice as much work to do what you can do by hand sometimes, and that's the price you pay in Angular. So you don't have like full control because of like two-way data binding, and that's where React was like, screw two-way data binding. Two-way data binding just like screws you over half the time, and so you have quote-unquote like manual data binding, where they essentially have like helpers to mimic two-way data binding for you, and I haven't had to use that when I used it because I was making a video player and like a YouTube, and I implemented that in React. And React makes your stuff or breaks apart your stuff in a way that's more manageable to me, which is you think about things as components, pieces on a web page. So I'm actually going to use this UI as an example of a component. You have this kind of like view over here. This entire thing is a component. That component has tabs, and there's 1, 2, 3 tabs. They have different behaviors, each of those tabs. So you have like this main tab, which is collapsible, and you have this other tab which then has a whole bunch of different features in here. To me, that's how I think of things. When you start breaking apart pages, you think of them as different pieces and have different building blocks. So like this is a tab, or this is an editor, whatever you want to consider, and it has a tab component. So you can say like this is kind of like a giant text area block with a tab attached to it, and you can say like this is a screen. The tab itself has a drop-down component, and that drop-down component contains all these things. And then you can say all tabs also have an X, and all tabs how to close themselves. And then all of a sudden you've built yourself a reusable concept of this X can close any tab. Because I click that X, I don't have to have all sorts of specific behavior. Same thing here, like I have a plus sign I can add. It creates a drop down. That drop down contains all of these things. Your new terminal can then be another drop down, and the drop down can contain stuff related to that component. And it just goes on and on, things you can think of as building blocks. And thank you very much, Synatic. I appreciate the follow. So yeah, the React way to me is better. So there's lots of React-like libraries as well. There's Mercury.js, which is one thing I'm heavily leaning towards. I'm a little bit I'm willing to go fringe-ish on my stuff. Mercury looks a lot like Angular, and you can write your code using JSX. There's actually a JSX converter, which is pretty simple. Things like, here you go, the Mercury versus React. Mercury is a total of 2.5k lines of code. Virtual DOM is 1.1k. React is 20,000 lines of code. It's only 11 kilobytes minified. React is, I think, like, I don't know. It's obviously 10 times as large in lines of code, so I think it comes out to roughly like 80 kilobytes, significantly larger in size. It's supposed to be faster, significantly faster than React, but while being extremely React-like. And then you got things like Mithril, which it seems very nice as well. It probably has a bigger community. Yeah, you can see like 3,300 people start it. You can see like it does controllers, views. In general, it's once again very React-ish like, and it seems to be pretty nice as well in what you can do there. And you can see like a little benchmark here for things like, you know, loading and then just performance for rendering. And the reason, like, generally React should be a little faster than Angular's rendering because of it using like dirty checking, and the more nested objects you have, the bigger your page is, the slower Angular gets in comparison to React. Then you have your hand-rolled jQuery, you have your Backbone, which you can see like Backbone is really good for performance. That's the thing, because Backbone is so small and so lightweight, it's actually a great system still. I've never actually written Backbone. It has a ton of boilerplate, which is its downside, but Backbone isn't bad at all. And like I said, I equate code quality not necessarily with lines of code, but it is a sign of quality, where if you can do as much as someone else with half the lines of code, they're either like you forgot about a lot of edge cases, or you're a better developer. One of the two. It's that simple. If you can do what I can do in 1/10 the code, that makes that an even bigger extreme. You're either significantly smarter than me, or I'm trying to do a lot more, or a combination of the both too. And React's virtual DOM system is actually supposed to be one of the slower ones out there, if not the slowest one. Here's VDOM benchmark. This is a benchmark with multiple different virtual DOM implementations, and I'll show you what I mean. Virtual DOM is the one that is used by Mercury. Mithril has its own virtual DOM system. There's other ones like Bobril, Maquette. Bobril is trying to build its own component framework. Maquette is trying to build its own framework. Maquette is very simple, so that's one nice thing. Like, if I were to tell someone like you want the simplest possible thing, Maquette is probably one of the simplest things out there from what I've seen. But React is also very simple. That's what I like about it. React doesn't try to be everything and everything. Angular tries to be everything and everything, anything and everything. I hate their dependency injection system. It's very Java-ish. And you might be like, well, makes things easy for testing. It's like, we're dealing with goddamn JavaScript. JavaScript is about as loosey-goosey as you can get. It's like the hooker down at the tavern or something. That thing is so open to do whatever you want that you don't need dependency injection in your language. If I pass you something that has the method open and you're looking to open a file, I've already made you a mock now. It's like I've mocked out my implementation because I can pass you anything with open on there. I don't need like this bloated function call with I'm passing this in blah 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 and dependency injected in for me. I don't really need that. It just feels like overkill in Angular world. I've used Angular. Like I said, Angular, if you're doing basic applications, super awesome. best by far. As things get more and more complex, you start hitting Angular more and more. So here's like general performance from React. Now I'm going to run basically it runs the same test. Here's the numbers from Virtual DOM. Virtual DOM in some of these tests are literally, this is not 10 times faster, but it's really fast. I mean, some of them are much closer, like here you go. I don't know if this is milliseconds or something along those lines, but some of them are just like mind-blowingly faster. 2000 versus 17,000 in lower is better. So this is 8 times faster, 8.5 times faster than the implementation in React. And this is using React 0.31. And so there's people out there creating some really good stuff that isn't React. Maquette is insane because it's a library that is 2.5 kilobytes or 3 kilobytes. And take a look at this. This implementation is insane. It competes with Virtual DOM, which is 1.1K lines of code. So it's probably about the same size and made by an independent guy. In certain cases, it's beating and still competes on almost everything pretty fairly. Wins in some other cases. This is actually one of the few cases it loses against even like Facebook. And so yeah, like there's people writing libraries out there that I think are better. React though is, if you want to go with popularity, things that you can trust to be around, React is going to be around for a while. It's not going to go and disappear tomorrow. Sorry, Synaptic. Or syntactic. So if you're, it depends on what you're trying to do with your backend development. If you're trying to do something that Game Meister actually kind of asked a question like this before I kind of like diverted from marking, which is fine because I wasn't going to do much else tonight, so I don't mind actually talking. The framework I recommend is, if you want to have a career and not be like me, and I'm not trying to say that you can't do what I do. If you want to be more marketable, let me rephrase that. Your framework choices today are Angular or React. I'd say those are your two ones. I wouldn't recommend anyone pick up Angular because they're rewriting Angular. Angular 2.0 is not backwards compatible with Angular 1. There's a lot of things that are changing from Angular 2, and changing in Angular 2. And there's a new framework that I haven't read too much about. I just kind of pulled it up. It's Aurelia. This guy made a framework for Durandal. Never used it. But basically, he worked on Angular 2, worked on the team, and I guess like he was hired by Google because he made Durandal and they wanted some of his expertise on this kind of stuff. And he basically said like, Angular 2 is not what I was hired for. Like, they basically hired me and it doesn't do what I wanted it to do or how I expected it to do. Aurelia seems pretty nice from what I looked at as well. It's kind of going, there's kind of two ways to do it. You either kind of keep yourself in JavaScript world, or you write your templates through HTML. And for me, I prefer using like the tools that I have in JavaScript. And what I mean by that is, I don't want to do this. I don't want to write if bind router.is navigating. I want to write an if clause that says, if router is navigating, add this into here. Otherwise, there's nothing for you to add, which is very simple for me. I don't want to write code like that anymore, really. It's just like, it's someone else had talked about it, not on my stream, but that I read, and they said it's mentally more exhausting because you have to keep in your mind, like, not just how to write JavaScript, but you have to remember all the syntax for their templating system. Technically, when you look at something like React doesn't really have much to remember. React is kind of like, okay, here's how a component's structured. Here's like the basic things that you have on a component, and everything else you don't have to remember at that point. You just go in, you just write JavaScript, and if you know JavaScript, you can write if statements, you can write, maps, you can do filtering, you can do all that jazz. If you want to do like special stuff, you have to handle like all this kind of weird syntax, repeat for. You need to remember those things to put on there. Aurelia, though, probably will be a pretty good one in the future. It's very, very new, though, because of the fact that, well, I think he started working on it in January, this framework. And there's obviously a lot more to his docs, and it's pretty nice, his docs, to say the least. Like, here you go, like, show.bind, if.bind. It's pretty explicit, where you say, like, bind, and it's very Angular-ish. Then you got things like Vue.js. Vue.js is, if you want to be more fringe, but you want to go, like, you're trying to find a balance, if you will, between fringe and popular. So this, it has 4,000 people who've started. If I go to React.js, I don't know if it's on GitHub. I'm assuming it is. Facebook React. This has 21,000 or 21.5k stars, so it's literally 5 times more popular than Vue.js. Vue.js is the most popular one that I know of, that I'd say, like, it's probably better in a lot. Vue.js is Angular. I had a friend who used it, so for a real actual thing. He liked it. There were downsides to it, but overall he was pleased with it. Vue is one of the fastest frameworks out there, and you can see, like, it looks like Angular in a lot of ways, and I'm sure since he's used it that it's only improved in, like, the 8 months or so ago that he actually did it. Let's see if I can pull up, like, the guide or something like this. We got a couple different concepts here. View models, the view, slightly modified, model, directives. Uses pretty much the same thing, Angular-ish as well. It has directives in here. And it even has components in here too now. The component, so you can create reusable components as well in Vue.js. Then they have directives, which are very similar to AngularJS. I don't know how. Yeah, you can see, like, the directive is drastically simpler. I don't know what other stuff it can do. I haven't used Vue.js, like I said, but Vue.js is another good alternative. If I go back to, like, that Google trend, we're gonna see, like, let's see, Vue.js is going to be probably minuscule. Yeah, see, like, Vue.js is all the way over here. It has, like, almost no. Ember.js is more popular than it. So if that's telling you anything, and I'm like, Ember.js is dying, I don't think Vue.js is dying, because there's people like me who use fringe stuff, not because I just want to use fringe stuff for shits and giggles. I use fringe stuff because I think a lot of the time mainstream overlooks better technologies. Because if you notice something, AngularJS backed by Google, React.js backed by Facebook, Ember.js backed by a lot of prominent Ruby members and stuff like that. Vue.js is actually, if I remember correctly, what do you call it? Made by a guy who works on or works for Google, or he did at least. Let's see. I could have sworn. Yeah, like he launched it in February of last year, and it got a lot of traffic, and a bunch of stuff. You can see like he kind of had a bit of a marketing kind of blitz on it too. I could have sworn he did it at least. And so yeah, I wouldn't suggest you get familiar with Node.js unless you want to work in JavaScript for the full stack. Node.js has its pros and cons. And if you actually do want to use Node.js, I would use io.js, which is essentially the fork of Node.js with updated like V8 and a bunch of other things. In fact, they just released io.js 2, I think it was, and it has ES6 features built in, so you can use classes already in io.js now, and so you can start writing, ES7 or ES6 code without any compiling it down to ES5. ES being ECMA script. So my recommendation, once again, was if you want something popular with a ton of momentum, and you're looking for marketability, React, because it's going to gain, momentum, and it's already, according to the Google trend, it's already blown past Angular. There's now, I don't know if this guy has done it yet. Hacker News hiring trends. He still hasn't done it. This will actually be a very good one to show off. React, Angular, Ember, and then there's even like Knockout. So you got Angular is this is job postings on Hacker News. Angular is still the clear winner in actual mind share, if you will, in terms of people who are using it. But the reason I say React is in a better position is because imagine the reaction basically people had when they found out Angular is not really going to be backwards compatible for the major rewrite, or there will be, but it's probably going to wind up being painful. The reaction was pretty bad. And so if you look at Ember has topped out at 12 in its history, 13, and the amount of job applications or job looking for people has increased over time. So Angular has steadily increased along with the posting counts. Things like Knockout have not. React is now at 28. You can see there's 3 times as many jobs basically, or 2 times as many jobs between Angular and React. But I feel like that's going to be one of those trends that as time goes on, Angular will ramp down, React will continue ramping up, and React will be the most marketable. And so that's why, like, a personal project like mine, if I want to go fringe and say, like, I'm going to use Mercury, for instance, like the most fringe of those choices, there's absolutely no one who can like fault me except for myself. And because Mercury is super React-ish to begin with, and it's very similar and was originally inspired by React, when it was like, I can basically let's create React without using React, if that makes sense. That he was one of the first people to do that, and so it's super close to React. And the skill and knowledge you gain from using something like Mercury is easily transferable over to to React.js, I believe. And you can just, change that stuff and change a couple paradigms as you need from, as you go from it. It's kind of like if you know how to program in one language and you learn in another language, it's always easier the second language you learn. Because you know the basics of programming. Now, not everything transfers, and so you learn the differences in how it works one language compared to another. Yeah, no problem. Angular is the documentation is a mess because there's so much to Angular. I felt like punching myself, well, not really punching myself, but punching the screen every time I had to deal with Angular's docs because they're always a mess. They're all over the place. There's so much to it that's like, good luck getting the kitchen sink example. Kitchen sinks are important in documentation. If you don't provide me with the kitchen sink, hardest possible thing to do, I will never be able to do the hardest thing possible because it's going to be like, well, you give me some of the pieces, but I don't necessarily know how to achieve it. And you should always treat any end user as a moron. If you can't get them to be able to do the most complex thing in your system possible, then your documentation is not good. You should basically be able to baby step them to there. And React, being so small and so focused, does what it does pretty well. The problem with React is it's so large, the library size. You go to angular.js, I don't know what the actual site, okay, it's .org. Okay, what? Oh, learning. I don't know if there's anything that says like the size of it. But it was pretty large, Angular. Angular is pretty large, React.js is pretty large, and the biggest criticism I have is like, Angular does all this crap, and it's about the same size as React. React has like so much less in it, and yet it is as large as it. But the nice thing about React is that I had interviews today, so I talked about this stuff as well. React, even though it's about templating and creating a component and technically the view for the component, it's essentially both your controller and your view. To me, your components isolate the logic necessary for controlling a component, and you don't have a traditional controller like this massive, like I'm on the homepage controller. Homepage controller technically is a homepage component. Homepage component has, let's say, a navigation bar, has a bunch of different things on here that you could have. This is pretty much just UI at that point. It would be like you can have a header component, you can have a footer component, you can have a content component, and that's your homepage. And that would be like full Angular. Now, when you don't really have interactivity, I'd basically be like, why are you having like, all this crap on this page that's static content as Angular? But that's aside from the point. You can have your search bar as a component on your as part of your nav, but all those things are isolated, and you essentially have like this controller already baked in through the concept of components. And then you manage the view through your component, and You just really have to worry about your data store and communication amongst components and to your server. So that's really the only hard part. React essentially reinvented the wheel by their Flux architecture, quote unquote Flux, is they came up with their own terms, dispatcher and like a data store. I can't remember what they called their data store. Flux architecture. Here we go. Flux overview. The Flux website. I didn't know they had a full Flux website now. Flux is dispatcher, stores, and the views. Dispatcher is, and it's like you should not be confused with MVC. It's like, okay, if you read through it, it's like, but it pretty much is MVC. They just, renamed it into their own, like, crazy thing. But yeah, you can easily do a lot of this stuff. And they have complementary tools like Immutable.js, which is for immutable data structures. And it allows you to speed up React by having references that are based off of basically pointers, where you can do, equality checks on data structures instead of having to descend through an object and say, has anything changed through any of these properties on the object? And having to recurse through that is the most expensive operation possible. So yeah, and that's my recommendation. And you can see like there's this kind of stuff here. Basically, action, dispatcher, store, view. View can then, essentially is like action being I click add on a screen. So I add a user into my database. And basically what it would do is like add user, dispatch it to the store. The store will then get updated, and then the view will re-render, essentially. And that's pretty much, action creators or helper methods, collecting the library, creating action from a method, parameters, assigning to type, provided to the dispatcher. Every action is sent to all stores via the callbacks, the store register with the dispatcher. After stores update themselves in response to an action, they emit a change event. Special views called controller views listen for change events, retrieve the new data from the store, provide the new data to the entire tree of their child views. And that's where they call it controller views, and I guess what you can say is a component is a controller view. It's, what is it, model view presenter? Well, actually it's not model view presenter, and it's not model view model. Ultimately, these kind of terms don't matter so much, because as you can see, someone like Facebook kind of it's very similar and very close and may even really be the same thing. And but ultimately, if you can achieve a clean architecture in some form or fashion, that's all that matters. And when I wrote Rome, it didn't work like this, but it had some similar concepts in there, like a component talk to another component through events. That's how communication occurred. Event was fired off, you listen for an event, you respond to the event. Your data store was essentially what I called an observable remote array. So observable remote array was a promise-based array that you could provide a URL for, have it call down to the server, get the data, then you can add data onto it to push on a new user. That would trigger an event off of the data, so you can listen to essentially this promisable array, say on or users.on added. You can go and respond to that, And it doesn't matter like that maybe I didn't write the world's best framework, and thus like everyone's not using it. What matters was like for when we used it, it organized our code to a great degree, and it made generally working in the code base really pleasant. So that's ultimately what matters. I feel like if you can get an organization and structure for your code that works really well for you, that's the most important thing you can achieve. Everything else is secondary. I don't care like if you're writing monads galore and you're the most awesomest person in the world. If your architecture basically dissuades you from working on it, it's not easy to add new things to it. You feel like you're repeating yourself a lot in your code. You feel like you're not getting a lot of reuse out of things. Either you're writing very unique things in that case, or you really don't have a good architecture in that case. So at least for me, quality of life, architecture is more important than like everything else in terms of like your actual performance. If you can't do things well in it, don't use it. Okay, so yeah, controller views are really components. Controller views call their own set state method, and everything else in the component tree. Single dispatcher, which is then a single dispatcher is an event bus. So like they're calling it dispatcher, but that's an event bus. An event bus is basically everything can register with the bus, and they communicate through there. Stores are pretty simple. They're a way to Angular has them in their resources. Your resources are your stores. I believe they do it a little bit differently, though. Okay, so this is basically some of their architecture choices, like dispatcher, wait for like Pentex, dispatch token, yet another store dispatch token. I don't even know what the dispatch token is. This is their to-do MVC example. With midshipmen and marines, better modify your coffin to take smithereens. Which means that you're keen to swim in Davy Jones' locker. When we're done with this fight, you'll have to walk with a Okay, so let's pull up JS. Here's app.js. App.js basically is, walking through this, we have a to-do app, which is stored in to-do app.react. Nothing crazy here. And it's loading the to-do app into the to-do app element. So now we have to go into components. Here's the to-do app. To-do app is the parent of them all, if you will. It's the root of all components in this application. And you can see like there's a get to-do state, which will return us all to-dos and are all complete. And to-do store is gotten from stores.to-do store. And basically to-do store is a repo, and you can consider it. I'm getting all to-dos, and really it's a little bit more too, because like they have are all complete, which is function off of there. So it's in reality it should be to-dos are all completed would be a function off there. So if we go to stores, here's our to-do store. To-do store takes a dispatcher, to-do constants. It has event emitting on there, and you can see a change event that it has. It has a create, so it randomly creates. This is, as you can see, hand waving here, not showing how this interacts with Ajax, a persistent. Basically, it creates a new to-do. in your to-dos, the to-do is an ID, so they're actually making an associative array up here, and some basic things here. So you have update, which calls in assign, update all, destroy, destroy completed, and it looks like assign is a basic way to basically do some, extending and object inheritance for them. So basically they're saying to do store is an event emitter. It has all complete, get all, emit change, add change listener, remove change listener, and then there's an app dispatcher, which it registers the entire thing. App dispatcher is what they were talking about in their actual Flux architecture, where I was saying like they have a single dispatcher which routes everything around. So we'll just jump directly into the app dispatcher, kind of walking our way back. And this is the Flux dispatcher. So really, you don't really get much out of that. It's basically all baked into this dispatcher already. What they have from their example. So going back to the store, so I don't know what this dispatcher actually includes. I can infer a lot of this. So basically it registers a callback, and this callback is, you can see that this is almost like event delegation. Really that's what it is. Event delegation is, if you're familiar with it, is a technique in JavaScript where instead of applying event handlers to each individual element on the page, you basically have a parent element you apply it to. So a classic example is a list. Instead of putting it on the li, each click event, you put it on the ul, and then you say, okay, whenever an li is clicked, I will perform some action. And when you add new LIs into your list or remove LIs, you don't have to do any cleanup or addition of more event handlers. This is essentially doing the same thing here. And what I mean by that is there's to-do constants of to-do create, and there's to-do constants toggle. We'll pull up the constants real fast. And these are basically, okay, that's interesting. All right, key mirror, all it's doing is actually taking the key and mirroring it as the value, which you can actually do in ES6. It's object literal shorthand, which will look like this. It would be like, to do create, to do remove, and that would be the equivalent of to do create, to do create, to do remove, to do remove. That's essentially what it would do. Technically this is quoted since it's a string, but you get the idea. It's pretty much that. So really, it's pretty basic constants. So basically what it's doing is, I'm assuming that event dispatchers, I would think they allow a little bit more granularity. Otherwise, they run through each of these functions. They basically create a whole bunch of events that they register. They execute each, pass in the action, and let each execute, which is possible too. That would make sense as well. So you can see, if I'm trying to do a to-do create, I basically have an action with data passed up to it with a text, which is a string. Then we create the text, and then we emit the change, which is going to be another event, change event, which is going to be simply change, is what's emitted on here. And then on change, we do a callback, meaning when the store gets updated, we tell people that we have been updated. And so like looking at this, this is even closer to the stuff that I mentioned before when I built my stuff. You basically have a data store. In this case, they use an actual like quote-unquote class to store this data, and then like get all will return the to-dos directly for you instead of like having a bunch of to-dos as more of a plain old object, plain old JavaScript object, or plain old JavaScript array. And so basically in this case, whenever you perform an action on here, you can see they emit a change. They tell people, oh, I've been changed, do whatever you need to based off of that. And so when I go back to components, go back into the to-do app, we're going to see, okay, we're going to get all complete, and we're going to get the state from here. In reality, they didn't need to break this up. This is just their choice of how to handle this. They could have easily, put this in here. They're basically saying once the components add an event listener and handle the, add a change listener and use this function for changes. So if we go down to onChange, all we're doing is setting state. And what they're doing, okay, this is why they broke up the state. Basically, they're saying, okay, get the current all to-dos, get everything that's complete, and that is your new state. Because it's pretty simple to think about. Like, if something has changed, if our to-do store has told us something has changed, well, just get all the to-dos again and know whether or not everything's complete or not in there. And the same thing, once you unmount the application, the to-do app, you can remove the change listener. You want to clean up after yourself, your destructor, if you will. It's essentially like constructor destructor. And so you have your header component, your main section. Main section gets all your to-dos as a property, and they're all complete or are also a property. So now I'm going to jump into the main section. Main section is meat and potatoes. The header is going to have like some basic stuff, things like onSave. onSave will say create, and create will pass in text. And so jumping up to actions, which we haven't looked at, to do actions basically will execute the dispatcher. So this is how they kind of do their event bus, if that makes sense. They never their actions are a facade over the dispatcher, if you will. So like when I call to do actions.create, it knows the exact format of how I'm going to use dispatcher, that it's going to look like it's going to be an object with an action type and a text. Action type, ID, text. Action type, and ID. Action type, ID, so forth and so on. So like the action knows all about the constants and what's needed between them. I'll archive this for you, so that way you can take a look again. And so let me like try and make a diagram, if you will, of this. So first, you really have constants in their architecture, at least. So I'm learning this as I'm telling you this, because I never really looked at Flux, largely because I blew it off as like, man, they just made the same shit and they just named it something else. In reality, they really did. Now that I'm reading it, so it's actually really easy to understand. But it works. It works. So like, what can I say? Like they renamed it to something that pretty much is easy and good architecture. So you have your constants. you have you have actions which will use those constants, and the actions talks to a dispatcher, a dispatcher, and the dispatcher is hooked into a store. A store knows all about the constants as well, so you can say it's almost a circular dependency of if you will. And I'd say you could arguably say yes, it is one. And this is my ghetto chart. I'm sure I can find some better tools. I think they actually have like have something like that. Drawing board. Yes, they do have a drawing board. Can I write text on here? Oh, that's downloading. So yeah, you basically, let me just go back. That's not going to really help me in drawing without text. So basically, you have kind of this dependencies where a store is also a little bit dependent on. Let's test this out more, because a store is also dependent on everything's messed up now. Okay, so you still have something like this. The reason we have this kind of like circularness going on is that constants are known by actions. Actions know about the dispatcher. The store knows about the dispatcher. And the store knows about the actions. The reason I say the store knows about the actions is how the hell else would the store know that I have a text property on my action, I have an ID property off my action, I have an action type, so forth and so on. So the store has to know about the actions that are possible and the data that would be passed to it. It's not blind, but there's nothing wrong with that, because when you think about event buses, you have I have object A listens for change. Object B emits the change, and with data about the change. Object A has to know what that data looks like in order to deal with it. It's as simple as that. There's no way getting around it. You loosely couple it in the sense that object A listens for a change, but that change can come from anywhere. As long as the change fits essentially the contract, you're good to go. And same thing, object B. As long as object B, it can be anything. As long as whatever emits this change gives you the data in the way that object A wants, it doesn't matter where it is, object B. And this is the same exact thing going on here. Is that yes, constants know about actions. Actions are known by the store, and constants know about the actions as well. So store knows about actions, and it's kind of a two-way street there. That a store knows about the actions, the action knows about the store, so that way it can achieve this. Object A listens for change, object B emits change. And constants are a part of that, both of these, because constants are used by the actions to delegate out to the store, so the store knows what to do. Another way to do this, or another way to think about this, is that constants are a weak version of your typical like events that you see in a lot of other places. So a lot of times you have like object A, emits added. Object B is listening for, removed, added, and changed. So and listens for these three things, and it listens to them independently. So like you might have object B dot listen or on like event bus dot on removed, and you have your function. You have something like that. And this is very typical. So object A is then like event bus dot emit, added. In this case, and we'll change this back, on added. So these two guys both talk through an event bus. That's essentially what the dispatcher is. The dispatcher is a dumb event bus. From just looking at this really quickly, the reason I say it's a dumb event bus is a lot of things have concepts of like topics, sub events or sub channels, whatever you want to call it. It's really just like a way to route a message properly. There's like signals.js. I think it's signals.js. JS signals, I guess. Event messaging system. You can see things like this: started add, started dispatch, started remove, and it does it a different way. JS signals doesn't use strings. This one uses non-strings, and it really comes down to like, do you like using strings or not? And you can say like, well, it doesn't really matter. At the end of the day, they both behave pretty similarly, or they should behave similarly. So yeah, object A listens for change, object B emits a change, and they use the event bus to communicate. The dispatcher is the event bus in this case, but normally you do something like, here's your data, which would equal something like text, and in their case, like in their example, ID, and then when you receive it, you would have something like your data. In their example, we have, going back to Facebook, we dispatch the event, and we tie it to a particular action types. So the routing is weaker in that you route it completely on your own. And what I mean by that is, if we go back up, and so the other thing that actions do here is they are like a repo in the database or a query, and you say like, let's see, like I want to get all users, like users that like get, might be some generic thing of like users with like February birth dates. You might wrap up a query like this: users with February B days. In a repo, you have your general methods of like, let's say todos dot all, todos dot like get by ID, todos dot add, todos dot update, you have those kinds of things on a repo, and essentially your calling in your actions are essentially controllers when you get down to it, where they're another form of a controller, because I say, okay, I'm going back over to I'm going to jump back here over into the components and go with the header. So on save, I'm going to call the action of create. And what are actions? Let's prove my point here. My point is, I have an index action, I have a new action, I have a create action, I have a show action, I have an edit action, and I have an update action, and a delete action. What does Facebook call this? A create, right here. On save, create. Okay, so I'm actually calling into a controller. My controller is then dispatching over into the data store. And we'll start seeing what looks very similar to what I've essentially written as real code. Okay, create, update, toggle is going to be an edit, toggle complete all is another edit, destroy completed. But the difference here, or the thing that's going on here, it's more like a remote procedure call into something that's like a controller. The reason I say that is you create actions. Well, you're creating actual commands that you're going to be accomplishing, and things that you want done. It doesn't actually do any of these things, if that makes sense. Much like a controller doesn't really do these things. It's dispatching out to someone else to do this responsibility. In this case, why does this keep having this? Okay. I've been trying to delete crap that I don't really need in here, which is all this code. You'll see, like, okay, I am pulling up all users, or let's say create being a good one. I'm getting the team ID, which is the text that was passed over. This is the text passed over to us, which in this case is coming from a URL from the submit action of creating, and I'm parsing it, and I'm saying, okay, let's go and insert this into the database. This is pretty close to it. Now, the only difference would be is instead of like wrapping this up into a chain set, I can have, I would have a team repo dot insert, right? Inside of here, I'd basically pass over something like this. Like, I'd pass that over to, well, actually I would just pass over team ID in roster params, or I would just pass over even something like params, and then underneath the hood I would have something like in the team repo I'd have a function called insert, and insert would then take the params, pull them apart, and do this, and then I'd return basically the same thing here. Is the change set valid? If so, well, actually the only difference is I would return basically success or failure, and it would do like all this code, and it would look very, very similar, and ultimately it would then say, like, if valid, do that, and then I'd do, this is Elixir right here, like okay, and I'd return like the model that was inserted, or I'd return error, and I'd return back the chain set which had the error on it. The only difference is that data doesn't flow back this way. I don't know how they handle errors. I'm sure that's the same kind of system, in that if I have an error, I basically notify a change event and we rerun the state. That's really the only difference. On the server side, I could do that as well. I could basically say, okay, I pass in the connection as well. Like, I could insert params, and I can pass in the connection if I wanted to into this team repo insert. And this would act as only a dispatcher inside my code now. Like, literally, I would have a create action going on. Create action passes over the parameters and says, well, you need to insert. Like, I've hit the create action, insert this bad boy. And now it's up to you to decide what to do from there, now that you've inserted. So it's very similar to creating, MVC. Despite what they may say, there are some slight differences because of how things behave, but we're not dealing with like earth-changing, world-shattering like new paradigm here. We're dealing with very similar concepts, just executed in a different manner. That's really how I'd describe it. Same concept, or similar concepts, different names, good results. So let's save that, and jumping back over to that repo again, or not repo, but the actions. So yeah, it's just dispatching all this out over to the dispatcher, and the dispatcher, like I was saying, oops, not that dispatcher, or choosing the dispatcher, and then the to-do store registers itself. And basically, since there's a single app dispatcher, the action is how we switch. It's a giant switch statement, and this is where I was mentioning that in traditional event buses, this basically breaks down into separate events. So instead of this, you would basically have event bus, on create. This would be a create function right here. This would be potentially event bus. Let's see. Event bus on to do on like to-dos toggled, or whatever naming scheme you wanted, really. That would be the to-dos toggled. And this would be event bus to-do toggled, really. That's the to-do toggle can handle both of them, really, in my opinion, because it's just an update action. You can see the same thing down here. They do the same thing. Literally, you could have a single action, and it's the not value of whatever was there, and so forth and so on. So it's super similar. And then it basically says I changed in whoever, and then it fires off, its change listener, or sorry, mid change. So anyone who's listening for that change event from there will get it received. And you can see like there's already boilerplate of some sort happening here. And the fact that like they have a change event, they have remove listener for change listener, add change listener. So yeah, there's some of that going on already, I can see from their architecture choice. And jumping back to header, that's the only thing that actually does anything. And the event handle is called within to do text input. What you'll see is that, which is actually weird that they chose to do this, because to do actions .create is global, meaning like the to do text input Actually, now I know why they did it, because to do text input is a generic input, like a text input, and you have different actions on there. To do text input is now, it has these properties, which is an onsave, the placeholder, IDs, class names, values, that kind of stuff. Nothing really crazy here. It creates an input with all those properties on there, and on the blower event, it fires off the save that you have. Actually, sorry, that's the wrong one. On the change, it fires off the. Was it? I could have sworn it was on change. Let me go back. The header. Yeah, it's on save. For the header. Yeah, so there we go, on save. Where is on save? Okay, there we go. And this is a little weird that they did that. So there's also local state for React. This is, sometimes its bane is that there's the concept of local state instead of only one state. Some people want local state, some people don't want local state. The benefit is, I believe, local state allows it to be faster by only re-rendering itself and its tree of components. So basically what's happening here is that we say, we're going to execute the onSave event with the value of the value of the text. And same thing, like we have update the change event, or update the state on the change of the text in the input box, so forth and so on, all these. And when you hit enter, we actually call save, and this will transfer up the stack of components because you passed in your function. Your function is, like I said, your function is in the header, and then the header executes the actual create. And now you can reuse the to-do because there should be a to-do in here as well, to-do text item. They actually didn't do that. That's interesting. They chose not to do that. I thought there was a way to edit it. There's a section, label. Oh, sorry, that's what it listed to-dos. And there we go. Yeah, to-do item is in there. To-do item should have a to-do text input, which is what I was talking about. You can see now, like, to-do text input has onSave, and its onSave is different. Its onSave is going to call update text instead of create, and so that's why, like, they set it up as such. Hi, Legris. Thank you for joining me, sir. Or madam. And so basically, you can see there's also on destroy click, and that talks to the action. The action, I don't think any of these has any reference to the store. There's only a single place that has a reference to the store, and that is up here, if I remember correctly. Yeah, you can see basically their entire architecture is based on this concept that a function will call an action, or sorry, your component will eventually call an action. The action will eventually call a dispatcher. The dispatcher will execute the store, the correct store method function, and then the store will say I've been updated and changed, and then a component will listen for that change from the stores it itself is interested in, and when those stores change, it will it will update all of the components as need be. And if I go into to-do item, once again, to-do item is basically just, and depending on if you're editing or not, it is an input. with the behavior that I stated before. Otherwise, it has the ability to be destroyed. Double click will basically change the state and say, oh, you're actually editing this input, and we now swap out the DOM elements for you to be what you want, which is why it's really nice. It makes it really easy to do this stuff. And you can see it's pretty simple to code and very easy to understand and follow through. That's why I liked React, was it did one thing really, and the way it did it well, and it wasn't overly complex to me as an end user. Let's see if there's anything else. There's also a footer. The footer basically does some basic things of like keeping counts. You can also clear all the completed items at once, and this will also call the to-do actions destroy completed. So you can see like each of these components can call an action. So any component can call an action. The way it works is kind of like going back up here to my list here. Excuse me. You kind of have like this side thing going on that this is a one-way one. Components. I guess I'll have to extend this out. She wrote these funny songs and everyone was tight. She asked me for advice on jumpstarting her career, but I'm staring in her eyes as she's talking in my ear. Suburban rap queen, I wrote this song for you. Suburban rap queen. So there you go, like action, constants know about actions. Actions know about a dispatcher. Dispatcher knows about a store. Store knows about actions. And actions know about the store. And those are kind of a much weaker emphasis. Don't worry, Lycris. If you don't understand something, I can definitely explain as best as I can. Although by 2 o'clock I'm going to be going to bed, since it's pretty late here, 2 a.m. And components know about actions. Actions don't know about components. So you can start thinking about like, okay, components are extremely isolated in that they only know about one thing in the world. Actually, no, they know about stores too. Let me correct that. So they also know about stores. And so I know this is kind of like hard to diagram. And so yeah, components also know about a store, and they know about the store in the sense that they listen for a store to change. They never directly act on the store, if that makes any sense. Components go through actions to cause the store to change, which then they respond to. They do know about certain pieces of the store, like if we go back, we go to the store, they know how to do things like, if we go through all of these, you'll see the actual public API is the following. To-do store only exposes get all, emit change, add change listener, remove change listener, and are all complete. So the only thing a component can do are one of these things. In reality, you could easily expose the following as well. You can expose the creates, you can expose the updates, but in their architecture choice and decision, they don't want you to do that. That's what Facebook has decided is the proper way to do this. Now, what would happen if I said I killed this? I feel like you don't need this. And what I mean by that is if a component knows about a store, and this is where like my my code when I wrote it for Rome was kind of like this, is that a component could know about a store and achieve pretty much the same thing. And what I mean by that is, let's kind of look at the code. In what magic, like black awesome magic, wait, it's not really black magic at all, but how they set it up, and why my argument is that you're not really gaining too much from it. It's creating, levels of indirection to keep things going in nice, but it's like I guess I need a more complex example of what dispatchers or a dispatcher and actions are doing for you. Maybe multiple dispatchers and things like that would make it easier. So if I go to the component again, we'll look at the header React. Okay, to do actions create. Why couldn't I call to do store.create text? If I pass that in and I go back to do store, to do store, so I said it right the first time. It takes a create, and you're like, well, you lose out on your change event. Okay, well, why not have this emit a change? Like, you can see, like, to create emit change, update all, emit change, update all. Like, why are they putting this in here? You notice how some of it seems redundant. Like, you could easily have your create, update all, destroy, and destroy completed, all with the emit change directly inside of there. So that then gets you the following. You can, if we go back here to the component of the header, you could call to do store.create, and someone would say, oh no, like, that's terrible. I don't feel that's terrible. The reason being is you're already calling the to-do store at a certain point to get your application running, and it's at the to-do app over here. Now you can say you're hiding the to-do store. The to-do store is not accessible to anything other than like the root element. That would be a better argument, I think. I don't know if it's really much better, honestly, because you have a to-do actions which is exposed all over the place through your component, and it doesn't really seem all that you really gain that much there. And so you can see, yeah, I have one place that can cause this event listener to fire off. And if we go back now to the header, if I did to-do store.create, and now let's say this was an asynchronous call, you wouldn't want to manually update the state. The reason being is, and this is actually the smart part of it, because you would do the following. You could up here, because of the fact that going up to, header. The header is where we call the create based off of the input being saved. The problem is you don't know if anything else cares about this to-do store, so you don't necessarily want to update yourself manually. You would possibly want to wait and let like the parent element respond to the change. You could still technically update yourself and set the state, but this is one of those like, well, I'm changing text. Now, I don't know who else needs that text change, so the header is isolated, completely isolated on its own. This is where the event emitting system makes sense. I create the text, and then I will do something based on it, and somewhere we'll do something based on it, I assume. or assume in the sense like, you as a developer assume that when I create text, or when you add this feature in of like to-do store.create, it's going to create something. It'll probably call down to a server. You'll have to wait for it to come back. So it's an asynchronous operation. Because it's asynchronous, you can't just like necessarily execute immediately from there, because there's lots of different ways this store could work. You might use the database as the one source of truth, meaning like you might pull the database every now and then, or when you update the create, or you call this create function, you manually call down to the server and you add this data in there. Or you might do something like you add the data in, and then you poll, and you continue polling, and you say, okay, now I got more new stuff. Because imagine doing a collaborative to-do list. Your to-do list, like you create one guy or one item, someone else creates another one. Now you're polling the server. You pull back the list and you update your list fully with everything on there now. And so I don't think it'd be terrible if you remove actions to simplify your life in a dispatcher and basically just have a store, and store is an event emitter. Because this is basically what I said. Like this is similar more or less to the architecture I made in that case, where components know about the store. The store doesn't know about the component, if you will. Or, well, it does know about the component in the loose sense of, like, it has a data contract that it has to fulfill of, you need to put data in like this. Now, you can make the argument, well, if you create a component, and this is where probably a lot of their arguments come from, they're a big organization. A lot of times when you go and start putting in more levels of indirection, you create architecture that's more maintainable across, a big organization. And so basically think of it like this. The actions know about the store, like I said. You never have to worry about, like, the store's, the interface for this, or sorry, the contract and the data that you need to send to the store is different. Now you need to go through every location that you call the store. So if you do store.create, and let's say instead of just passing text, it's now an object. Since your action is a facade to your store, you essentially hide that change. And you can say, everywhere is passing, to do store.action, to do action create, and it's passing text to me. Well, to do store is actually expecting now, like, for its create, some, like, data, like text, and like type of text, I don't know, status or happy, or I don't know, maybe it's looking for something like this now on your to-do list. And so what happens is inside of the create function, so like this create function says, I know what the data contract is for to-do store. And so like when I dispatch, I'm actually going to go and say, I'm going to hard code, do a check, like as people update their, I check like if string do X, else, it's an object, and I can return it and it's already the right type. So you basically say like, data is, this object. It looks like the one below now. So it'd be text, awesome, and type, happy. You've now saved yourself from having to go through the entire code base and rewrite. Well, it's not really rewrite, but refactor that change. And so like I've now changed that contract to say that I expect an object instead of just text. And if you had written to-do store create and you had multiple places that could somehow create text, you now have to change them all. The problem with this example, the to-do list, it's very easy to be like, well, this is super simple. Like, why do I need, like I said, actions or a dispatcher? And I actually believe, despite what I've said here, often is not going to be needed in simpler and smaller teams, dispatcher and actions. So you can essentially like kill this. You can kill that, and you can kill the actions, and you can call a to-do store directly. And there's still, like I said, ways to achieve all this stuff without doing it. Classic example would be using AJAX calls, and I'll show you what I mean. Well, I won't really show you, but I'll explain what I mean. Wrong one. To-do app. In the component did mount, you can make an AJAX call. Your AJAX call can then get the data, and then you can do something like on state changes. On state changes, you can go and fetch the data from the server again. So you're like, oh, this changed, and let me go fetch it from the server. There are definitely benefits to this and this approach, don't get me wrong. Abstracting out your store. Oh yeah, it's 2:03 now. I still also need to take out my dog for her like last walk before I go to bed. So yeah, and that's pretty much Flux architecture in a nutshell from that to-do MVC. And you can see like let's see, to-dos register callback would be explicitly wait for any dependencies. So it's a little bit more complex there too. You can see like they have things like wait for dispatch tokens. I have no clue what the hell this shit is, honestly, especially at this point at time. But you can see like there's more to it, and the more complex your application gets, the more those kinds of things will hopefully be useful. And like I said, creating a dispatcher, they even have like naive dispatcher. That is essentially the to-do MVC example. It does a whole bunch of stuff for you, and you can see like they do this. And there's people who've made more intelligent, I'm sure, some more intelligent design decisions based off of this. And what I mean by that is, wait for, let's see. Oh, that's the wait for example they were using. Dependency management for your dispatcher, and that kind of stuff. And so you can see over here, a lot of people ask if Facebook will release Flux as an open source framework. Flux is an architecture, not a framework. But yeah, they're saying like Flux boilerplate project might make sense. And really it's like, here's how you architect your system. And this is what I was talking about earlier, where if it's not easy to work with this system, then your system is bad. And if your system is bad, then everything is bad. You're not going to enjoy yourself. And dependency management to the dispatcher can make sense. I think when I was working on the video player, I came into an example that kind of like, I do not understand how to achieve this. This is completely broken in React. Like, they don't support this well. And what I mean by that is, I had this weird state change. So if you're watching a video and your video ends, meaning like the person who was streaming the video finished streaming the video, I'd say, oh, this video has ended. I should like show you the next available video, or get the next stream that is available for this user. The problem is you should be able to finish watching your video before I switch you to a new video. And so basically I would have to let the video play out, not update the state for anything else yet. I'd have to save what the next video is going to be and update that state, and then say, okay, when you finish watching the rest of the video, now you can change the state. And it created like weird behavior there. And that was probably one of the more like arcane kind of uses of React. So maybe something like Flux with, a wait for would have helped, where I could have been like, okay, wait for like the dispatcher or whatever the hell else out there, wait for like the video player dispatcher to tell you everything's a-okay, continue on, and now admit the change. So something like that could have helped there. And chat is easy. Like this is really easy. Yeah, and they have a whole bunch of other stuff: register, unregister, multiple dispatcher, or a dispatcher, flight dispatcher, and I have no clue what dispatch token actually is. Oh, dispatch token is basically it returns a token for wait for. Interesting. They don't actually show an implementation. Here's the source code. This was actually easier to see. I can understand that, I'm sure, much better. Register is actually... Oh, that's all it is. Register is just returning an ID, which is prefix of... The hell's the prefix? Just ID plus a number. That's nothing special. And the callback, and returns you the number. So then like a wait for gets you actually just a bunch of IDs. And they're using ES6 in here. They basically say that dispatching and wait for must be invoked while you're dispatching. So you wait for all these things to finish, and once they finish, you can invoke the callback for that particular ID. So it was actually a lot less complex, and I realized, array of string of IDs, and waits for the callback specified to be invoked before continuing execution of the current callback. So basically, yeah, and this would be like your synchronous call right now. At that point, you would sit around waiting for something to happen before you continue on to there. So like, let's see. And that's why they're storing dispatch tokens like this every time you register. And then chained wait for. Let's see, is there another wait for? Yeah, so the city store can wait for the flight dispatcher can wait for the country store dispatch token to complete, and then the flight price store inside of there can wait for the city store's dispatch. So you can see like they're chained amongst each other. First, the country store needs to complete before anything else will continue on. Once the city store completes, the flight price store can complete, and so forth and so on, as it cascades down. So the wait for is probably, gives you a good reason for like why you might need it. In a lot of cases you wouldn't. At least my opinion is a lot of cases you won't. This is where like, if you start with a more complex architecture, even it often still pays off. because you don't have to re-architect things later on. And the benefit of, like, if you are going to use React, there's already, like, let's see, libraries lists. Awesome React. There we go. List of whole bunch of things. Flux tutorials, implementing Flux, async requests with React.js and Flux, sample application, Flux versus Reflux, a bunch of different things. Other thing is React has React Native, so you can start building apps using React with JavaScript and a whole bunch of other stuff. Let's see. Reflux. Any other ones? There we go. Flux. There you go. Here's all your Flux implementations done already for you. So that basically, and it looks like someone already made a comparison of all the different Fluxes. Practical comparison of different Flux implementations. So this has pretty much everyone. Fluxible by Yahoo, FreeFlux, Alt, Flumux, Marty, JS, McFly, Lux, Material Flux. He needs to add in DeLorean, Fluxor, Finks. So there you go. Like, pretty much there's everything possible, if that makes sense. And there's also Riot.js, which is another one out there, which is a minimal framework. But yeah, you can see, like, they're flustered with Flux. This is like boiling it down into a lot more things. You can see user interactions call actions, which then go into dispatcher, which callbacks into store, change event, React views. And this will be your web API utils and web API. Does he have a graph or chart of that? Yeah, this is exactly what I was talking about. Stores, a component calls actions. Components listen to stores. Stores listen to actions, and actions obviously call the store, or technically changing the code. Components listen to stores and call actions. Stores listen to actions and toot when they're updated. So there you go. Like, this was how I was mentioning, like, you may not need a dispatcher, and so you can do the same thing with actions. And how I was explaining, actions make sense more so than the dispatcher. And there's so many different implementations of the general architecture that's, like, for you is the way you should do things, not just because, like, unicorns and rainbows. Anything that makes it unicorns and rainbows for you is the way to do it. Alright, so hopefully that gives you, like, a good idea of the breakdown of React and how to generally use it. That to-do MVC is actually a pretty good one because it's basic enough, but with the more complex, like, Flux architecture to get you going. And then there's Awesome React, which is a GitHub account, or GitHub repository with a collection of quote-unquote awesome stuff for React. And there's a lot of stuff for that. Like, there's Awesome Elixir, Awesome Remote Jobs. So yeah, this is one for Elixir, the programming language that I'm using. So same exact thing. Like, you can see a whole bunch of shit for me ready to go that I can go and read about and look at and break it down already for me. So that's it for me tonight. I spent a lot of time, like, going over React and some of some of their code choices and what I think of for those code choices. But yeah, I think that should give you like a good start on everything for at least like React, and you also now have like somewhere to go on like if you want to continue using React, use one of the more fringe things, go to Angular, or even go over to Ember, and so you have all those things to think about. So hopefully, let's see. Hopefully everyone here who's still here has enjoyed the actual talk. So I'm going to be heading to bed now. So enjoy the rest of your evenings, or enjoy your